Hi there. In this video, we'll be learning how to find the parts of an ellipse given its equation. To start, let's consider this equation of an ellipse with a greater than b. This means that this equation represents an ellipse that is oriented horizontally. From the equation, we can immediately obtain certain parts of the ellipse. We can obtain the center of the ellipse since we have h and k out here. We can also obtain the length of the semi-major and semi-minor axis since we're given a and b out here. We can also obtain the major and the minor axis since these two are just twice the semi-major and semi-minor axis respectively. So these are the parts that are easily obtainable given the equation of an ellipse. However, there are certain parts of an ellipse that aren't quite easy to obtain compared to these. These parts are the foci, the vertices, and the co-vertices of an ellipse. So by the way, if you don't know the parts of an ellipse, I have a previous video discussing that one, so that you may check that one out to have a better background on what these parts or how these parts are defined in an ellipse. So continuing, let's go over these parts one by one, starting with the foci. So for the foci, how do we obtain this foci from this equation? The key thing to remember is that we know the length out here, which is represented by c. This length out here is given by the square root of a squared minus b squared. How did we obtain this one? You may check out a previous video deriving the focal distance of an ellipse. And as you can see, c equals square root of a squared minus b squared. Both a and b are obtainable from the equation of an ellipse. So we can use this value, c, from the equation. So using this one, we can now obtain the value of this focus and this focus out here. We just take note that using the center, which we know is given here, h and k, to obtain this point out here, we just move this point to the left. That is, we adjust the x-coordinate out here. Moving it c units to the left, that is, we subtract c in h out here. So we'll have h minus c comma k out here. That would represent the first focus. For this next one, we just do the opposite. We add c instead. And so we now have our 2 points for the foci. So that is how we obtain the foci of an ellipse. Next, let's go on to the vertices. By definition, vertices represent the endpoints of the line segment. So if we treat this one as a line segment that passes through the center and the foci of an ellipse. Its endpoints are on the ellipse. So how do we obtain this one? Take note that since we are given the center and we know that from the vertex, one of the vertex to the center, its length is given by a. So the same goes for this one. This one is also length a. There. This means that, similar to how we did in the foci, we'll just adjust the x coordinate out here since this one is a line along the x-axis. So to get from this point to this point, we simply subtract a out here. Oops. There. So we'll have here, there, h minus a comma k for this first vertex out. For this other one, we simply do the opposite, and that is we add a. So we have h plus a comma k out here. And so that is how we obtain the vertex of an ellipse oriented horizontally. So far so good. It's very intuitive. And let's now move on to the last part that we still don't know, which is the co-vertices, these two. The idea in obtaining this one is similar to how we obtain the vertex or the vertices. We take note that by definition, the co-vertices represents the endpoints of a line segment passing through the center that is perpendicular to the major axis, this one. So it is along the y-axis. So given the center, and taking note that we have here this length, there, the length of the semi-minor axis, which again is obtainable since we have b in the equation. We can now obtain the co-vertices. This time, since this one is along the y-axis, what we adjust instead is k out here, the y-coordinate. So we subtract and add b in k. That is, we'll have the point h k minus b and the point h comma k plus b. And so these two are the co-vertices of the ellipse. And so we now have a value for each part of the ellipse with just given its equation. To summarize, given this equation of an ellipse, that again we know is oriented horizontally, its center is given by the point hk, the semi-major axis is given by a, which follows, we can obtain the major axis, just 2a, the semi-minor axis, which is just b, and to obtain the minor axis, the length, we just multiply 2. So these first 5 parts are very easily obtainable. For the last 3 parts, we obtain the foci by subtracting and adding the value c, this one, to the x-coordinate of the center, and we obtain the vertices by doing the same, but this time we're subtracting and adding the length of the semi-major axis to the x-coordinate. For the co-vertices, what we do is we subtract and add b to the y-coordinate, which is k, of the center. And so that is how we obtain the parts of an ellipse from its equation. So you may take a screenshot of this one if you want, as we would go on some examples in the next video. But a good question to ask before we end this one is, how about for vertically oriented ellipse? Well, that is something that I would leave as an exercise. Essentially, the strategy in obtaining these for a vertically oriented ellipse is similar to how we did out here. You'll just consider an ellipse that is oriented vertically, and then there would just be some minor changes in the foci, the vertices, and the co-vertices, since like in the foci, instead of subtracting and adding c in the x-coordinate, we instead do that for the y-coordinate, since we know that the foci for a vertically oriented ellipse is along the y-axis, something like that. But that's something that I would reveal, so the answer would be revealed in the next video. But it's a good exercise to try out if you truly understand how this works. So yeah, that's it. I hope you enjoyed and learned a lot from this video. Feel free to comment down below if you have any comments, suggestions, recommendations for this video, this playlist, and this channel in general. So yeah, that's it, and that's all for this video.